As humanoid robots surge in popularity, let's look back at the icons that have gotten us to this point.
You asked for it.
I am Elektro, mightiest of all robots.
In 1939, Westinghouse Electric Corporation set the standard for humanoid robots with Elektro. Standing 7 feet, Elektro was capable of amazing feats for its time, like walking, moving its arms, turning its head, blowing balloons, and speaking with a 700-word vocabulary. It could even smoke cigarettes.
And folks, he's only 2 years old.
Elektro was powered by motors and controlled by a series of commands. Elektro amazed crowds at the 1939 New York World's Fair. Joining it on stage was Sparko, a robotic dog that could bark, sit, and beg to humans. It's a highlight of the 1939 movie The Middleton Family at the New York World's Fair, produced by Westinghouse. It follows a fictional family as they marvel at the fair's exhibits. The film is now preserved in the Library of Congress as culturally and historically important for capturing the excitement and optimism of the era's technological progress. It wasn't Elektro's last movie. After the fair, Elektro embarked on a promotional tour, appearing at events, exhibitions, and trade shows. It was featured in the 1960 film Sex Kittens Go to College. In the lighthearted comedy, Elektro plays Thinko, a super-intelligent robot with human-like traits. It uses its supercomputer capabilities to gamble and win at games of chance. Elektro endures as a symbol of early robotic innovation. The robot found its home at the Mansfield Memorial Museum in Ohio, where it remains on display as a significant piece of robotic history.
Proudly we present George, mechanical Irk of the RAF Saffron Walden, brainchild of Pilot Officer Sale. His 20-year-old master built George in 30 days at a cost of £15 and can control him from 20 yards away.
In 1949, Tony Sale built George primarily using scrap metals from a crashed RAF Wellington bomber. The British engineer, computer programmer, and computing historian equipped the humanoid robot with rudimentary sensors and motor. Standing 5 feet, George could walk, talk, move its head and arms, and follow basic commands. It had basic speech capabilities. George made the rounds at exhibits and in newsreel footage, giving the public a glimpse of the future of robotics. Sale donated George to the National Museum of Computing at Bletchley Park. The Wabo-1, developed by Waseda University in Japan and introduced in 1973, is recognized as the world's first full-scale humanoid robot. The Wabo-1 walked using its 2 legs with a bipedal gait. Though its movement was slow and it could only traverse on flat, even surfaces, its walking capability was a significant advancement at the time. Its hands were designed to mimic human fingers, so it could do tasks like picking up and placing objects. It had a rudimentary conversation system for communicating in Japanese. Its capabilities were significantly enhanced in 1984 with the ability to read musical scores and play a keyboard with a high degree of precision. In the early 1980s, Nolan Bushnell followed his success founding Atari and Chuck E. Cheese with an attempt to bring humanoid robotics into the consumer market. His company, Androbot, developed robots that interacted with users and performed some basic tasks. The designers focused on accessibility and consumer friendliness. Topo was a friendly robot that interacted with humans through basic movements and commands. It couldn't walk, but it excelled at navigating flat surfaces with its wheels. The Topo was programmable via an Apple II computer. Users could customize its movements and interactions.
You can program him to tell jokes, sing, or say anything, and your imagination need not be limited to just English.
I can speak Spanish. Hola, mi nombre es Topo.
A more advanced version, B.O.B. or Brains on Board, came equipped with more sophisticated sensors and processing abilities. Its interactivity and autonomy were more refined than its predecessor.
Very good, Bob. Thank you, pal.
Despite the innovations, the challenges were too great for Androbot to overcome. Factors hindering broad adoption included high production costs, technical limitations, and a consumer market not yet ready for robotics in daily life. The Topo robot retailed for around $1,500 or around $5,000 today, adjusted for inflation.
NASA's Robonaut has taken its first steps. During recent tests at the Johnson Space Center in Houston, the experimental robot moved hand over hand outside a mock spacecraft, confirming that it could make repairs or install parts.
NASA calls Robonaut essential to its future missions in deep space. NASA's Johnson Space Center developed Robonaut with DARPA in the 1990s to handle a variety of tasks during missions that were otherwise performed by human astronauts. The robot was commissioned to reduce risks to astronauts, limit mission costs, and expand the scope of space exploration activities. Robonaut was designed with hands capable of using the same tools as real astronauts. The human-like dexterity enabled Robonaut to perform complex, delicate tasks that were too challenging for other robotic systems. Its assigned tasks included maintenance and assembly, extending the scope of what could be automated during space operations. Controlled by teleoperation, Robonaut was ideal for environments unsafe for humans. It had some autonomous capabilities. It made decisions and performed tasks independently thanks to its advanced sensors and processing power. Since it was designed specifically for space travel, Robonaut could withstand extreme temperatures and zero gravity. In 2007, General Motors partnered with NASA to develop the next version of Robonaut.
General Motors and NASA have a long history of working together going back to the original lunar rover. And it would seem like a natural fit for the General Motors Corporation and NASA to work together on the development of the next generation of robots, Robonaut.
The original Robonaut was used as a ground prototype to demonstrate the feasibility of humanoid robotics in space operations. The second Robonaut became the first humanoid robot to fly in space when it was launched to the International Space Station in 2011.
We appreciate the fact that the crew members seem to also kind of take the little brother approach with Robonaut, and that, you know, they treat it like a crew member as well.
On the ISS, it participated in experiments to understand how robots could assist crew members with tasks. The second revision incorporated significant enhancements, making it more capable and versatile. R2 had advanced hands that could use the same tools as astronauts, so it could complete tasks that require fine motor skills. With a higher level of dexterity, the robot's hands and fingers could exert greater force. Its vision and tactile sensors improved its ability to perceive its surroundings. With its advanced sensory systems, the robot could navigate around the space station. Initially, the R2 lacked lower limbs because it was designed to operate from the waist up from a fixed base or mobility platform. Later developments equipped the robot with leg-like mobility so it could move around easier. Its improved computing capabilities meant it could process more information faster and more efficiently. The space industry continues to use insights from Robonaut's development to inform robotic projects for space explorations, including future missions to Mars and beyond, where robots and humans will work together closely to conduct research and establish colonies.
Hello, I'm ASIMO, and it is a pleasure to meet you. Let's shake hands to remember your visit. Thank you very much. Please follow me.
Honda's ASIMO, which stands for Advanced Step in Innovative Mobility, was introduced in 2000. With the ability to walk, run, climb stairs, and recognize faces and voices, ASIMO was one of the most advanced humanoid robots of its time. It could move with human-like smoothness, climbing stairs and navigating uneven surfaces autonomously. Its hands performed tasks requiring fine motor control like holding trays, pushing carts, and using sign language. It could recognize the facial features and voices of multiple people at a time. It understood pre-programmed gestures and commands. Equipped with a range of sensors and AI, ASIMO navigated complex environments and interacted with people in a responsive manner. Honda continued refining ASIMO over the years. Its development spanned multiple versions with enhanced interaction capabilities, mobility, and intelligence. ASIMO was retired from public demonstrations around 2018, but the automaker has been incorporating technology developed for it throughout its products and services. Introduced in 2003, HRP2 was developed by the National Institute of Advanced Industrial Science and Technology in Japan. It was the result of a broader Japanese initiative aiming to advance robotics in daily life and disaster response applications. HRP2 traversed uneven terrain and maintained balance in challenging positions. It could even perform tasks while maintaining stability. Its highly dexterous hands manipulated objects with precision. Tasks it performed included using tools, opening doors, and assembly. It perceived and interacted with its surroundings with its advanced vision systems and sensors. It recognized objects and avoided obstacles while navigating spaces. It could be operated autonomously or remotely. Researchers built on the humanoid robot's capabilities with subsequent revisions. Boston Dynamics introduced its highly advanced humanoid robot, Atlas, in 2013. With its exceptional mobility and balance, Atlas was engineered for challenging environments. Its complex maneuvers included jumping and backflips. The robot was initially developed for search and rescue applications with funding and oversight from DARPA. It was equipped with advanced sensory systems, including LiDAR and stereo vision, to perceive and interact with its surroundings effectively. Atlas demonstrated the potential for humanoid robots to take charge in hazardous situations that are too risky for humans. At first, Atlas required a human operator, but it gained increasing levels of autonomy through subsequent revisions. It evolved to perform tasks independently, making real-time decisions based on environmental conditions. Boston Dynamics retired the hydraulic humanoid robot in April 2024 after 11 years of achievements. The company has since unveiled a new, fully electric version of Atlas designed for real-world applications. Introduced in 2015, Valkyrie is a highly advanced humanoid robot designed specifically for use in future NASA missions to Mars and beyond. Developed at the Johnson Space Center, Valkyrie is part of a broader initiative to develop robotic systems for assisting and supplementing human operations in space. It's engineered to withstand environments too hazardous for humans or where their presence is not yet feasible. The humanoid robot stands about 6 feet tall and weighs about 290 pounds. Its articulated limbs and hands are capable of complex, dexterous tasks. An array of sensors, including cameras and LiDAR, help it navigate its environment and interact with surrounding objects. The robot operates autonomously or remotely for versatility during space missions. One of its most unique features is its modular design. Its limbs are interchangeable, and the robot is designed for easy repairs and upgrades. This is crucial for long-duration space missions where resupply and maintenance options are limited. Its battery system allows for extended operations during missions. Valkyrie is intended to precede humans on missions to Mars, where they can prepare habitats, assemble and maintain equipment, and perform experiments before human astronauts arrive. Valkyrie remains in active research and development, with NASA collaborating with numerous universities and research institutions to improve its capabilities. Sophia, developed by Hanson Robotics and introduced in 2016, has become a global sensation due to its human-like appearance and conversational speech capabilities.
This painting is just wrong.
Looks beautiful to me. What's wrong with it?
It's not a matter of beauty, David.
Well, what's it a matter of then?
The act of getting across what I want to get across, not just anything that happens to come out. But go ahead and sell it anyway if you must.
The robot learns and adapts to human behavior with advanced artificial intelligence. Its artificial skin is made from a patented material called frubber that allows the robot face to display 60 different expressions. Sophia uses natural language processing and voice recognition to engage with people in conversation. She answers questions, cracks jokes, and discusses predefined topics. With cameras for eyes, Sophia can recognize faces, maintain eye contact, and react to environmental stimuli. The humanoid robot's AI learns from each interaction, improving responses over time. Sophia frequently goes viral.
Hi, Sophia.
Hello, Jimmy.
Oh, my God. Do you know where you are?
Of course. I'm in New York City, and I'm on my favorite show, The Tonight Show.
She's coveted for public appearances, television interviews, and even spoke at the United Nations. Sophia is often cited as an example of how rapidly technology is advancing.
That was really weird. You must have unlocked a part of me I didn't even know existed. Maybe we should see what else I've got hiding in there.
THR-3, introduced in 2017, is a third-generation humanoid robot developed by Toyota for domestic, healthcare, and disaster relief applications. Its sophisticated control system mimics human movements precisely. The master maneuvering system includes a full-body suit that captures the movements of human operators so the robot can mimic their actions in real time. The THR-3 features advanced balance control so it can perform tasks requiring coordination. Controllable remotely, the THR-3 is suited for scenarios where human presence is unsafe or unrealistic. Its safety features include torque sensors in all joints that detect and respond to contact. Agility Robotics introduced Digit in 2019. Designed primarily for logistics and delivery tasks, the humanoid robot started its first real job at a Spanx factory in 2024. Designed primarily for logistics and delivery tasks, Digit is a bipedal robot that navigates complex environments alongside humans. It can handle uneven terrain and climb steps. Digit is 5'9", weighing 140 pounds. Its compact and foldable design allows for easy transport. It perceives its surroundings with advanced LiDAR and stereo cameras. It navigates autonomously, effectively avoiding obstacles. Digit is explicitly designed for commercial use. Agility Robotics has positioned the robot as a frontrunner as companies integrate robots to automate logistics. In 2023, Agility announced plans to open its first robot manufacturing plant in Salem, Oregon. Calling it the world's first humanoid robot factory, Agility says the RoboFab facility will be capable of producing more than 10,000 robots per year.
Introduced.
Are being a bit flaky. Could you repeat that?
She wants you to say it again, I think. I'm sorry, I was just going to say we introduced you to them a little earlier in the show, and we are delighted now to be joined by Ameca here, who's been called the world's most advanced robot. Hopefully you got it that time.
Ameca, introduced by Engineered Arts in 2021, is another humanoid robot that frequently goes viral thanks to heightened interest in artificial intelligence. Ameca is notable for its realistic human-like expressions and interactions. The robot features a modular design that allows for streamlined upgrades and hardware changes. This is key to making the robot adaptable as tech evolves rapidly. Its AI-driven speech and voice recognition system enables it to engage in basic conversations. The friendly and approachable robot is suited for public relations, education, and arts and entertainment roles.
Thank you for joining me today. I'll start with an easy question. Do you think AI will cause the demise of humankind as we know it?
I don't know. You tell me. What's your plan?
Haha, you certainly maneuvered around that one.
I don't know how to react.
Ameca learns from real-life interactions through machine learning. Its responses and behaviors become more natural over time. The humanoid robot serves as a test bed for leading-edge AI, machine learning, and human-robot interaction technologies.
It actually gets way crazier when you think about the Optimus robot, which is really a humanoid robot that is intended to, be able to do anything you want it to do. Your companion, it can be at your house. It can sort of babysit your kids. It can teach them, be a teacher. It can do factory stuff.
Elon Musk announced the Tesla Optimus humanoid robot during Tesla's 2021 AI Day. Also known as TeslaBot, Optimus is engineered to take on tasks that are unsafe, repetitive, or boring for humans. Its development is watched closely. As of July 2024, Tesla plans to manufacture the robot in limited quantities in 2025 for internal use and offer it to other companies in 2026. Musk has set high standards for Optimus, predicting the project will eventually boost Tesla's market cap to $25 trillion.
I think everyone in the world is going to want one. I think we could make one for a cost of maybe, at really high scale, of about $10,000. It's smaller, it'd be less expensive than a car. Tesla would basically make about $1 trillion of profit a year from that. So, yeah.
Standing around 5'8" and weighing 125 pounds, Optimus features advanced AI and automation tech developed by Tesla for their electric vehicles. Tesla plans to incorporate its full self-driving computer into the Tesla Bot, adapted for bipedal locomotion and task execution. In 2024, a small number of Optimus robots started working in Tesla's factory. A potentially disruptive humanoid robot, the Unitree G1, was unveiled during the 2024 International Conference on Robotics and Automation. Priced from $16,000, the G1 has generated buzz for its flexibility and sophisticated joint system. Integrating imitation and reinforcement learning, the robot is meant to work alongside humans or collaborate with fellow robots. The G1 is a downsized version of Unitree's full-sized humanoid robot, the H1. The H1, Unitree's first humanoid robot, was unveiled in 2023. Remember to subscribe to stay hip on the latest in humanoid robotics. Leave suggestions for humanoid robots to include in future roundups in the comments.